So we spent the last couple days talking about distance, the length of a segment. Today we're going to transition and talk about midpoint, so the halfway point on a segment. This video, I apologize in advance, is probably going to be a little over 10 minutes just because there are two longer example problems that I want to get through. I want to get through them so you have them in a video example when you're at home studying or doing a Google form check. You can always watch this video at a faster speed. YouTube has an option to do that within settings. Just a reminder too, you can always pause these videos at any time to take notes. So maybe the things on this slide are things you would want in a notebook if you are a notes person. A midpoint by definition is a point that divides a segment into two congruent segments. Congruent is just a vocab word that means equal or the same length. So in the picture off to the right, point M is the midpoint. It divides segment AB into two equal segments, which are shown by those red tick marks. A segment bisector is a line that intersects a segment at its midpoint and cuts the segment in half. So the blue line here is our segment bisector. The angle that it crosses the segment with doesn't matter. All that matters is that it goes through the midpoint. All right, we're going to use the definition of midpoint then to solve this problem. Point S is the midpoint of segment RT. By definition, that tells us RS and ST are congruent segments. Step A has us write an equation and solve for X. So I know RS, and that means the distance between point R and point S is equal to the distance between point S and point T. I want to write an equation that allows me to solve for X. So I have to get my X's in place somehow. I'm just going to take those two things. I'm going to substitute in what I know. So RS in the picture is given by 5x minus 2. ST is given by 3x plus 8. This is an algebra problem. You all took algebra last year, so you should be algebra experts. Our goal here is just to solve for x. I'm going to subtract 3x on each side. That would get me to 2x minus 2 equals 8. I want to get x alone, so I'll add 2 to each side. 2x will equal 10. And then I want to get that to be just 1x. So I'm going to divide each side by 2. And x should be 5. So that's my solution to A. And then B wants me to find RS and RT. We're going to have to go back to look at our picture to do that. RS is given by 5x minus 2. We know x is 5, so I'm just going to plug that in. 25 minus 2 would be 23. So RS is 23 units. Next, I have to find RT. So there are a couple different ways you could do it. Read these problems carefully. Notice RT is the entire segment. So you could say RT is equal to 5x minus 2 plus 3x plus 8 and plug 5 in for all your x's. I'm not going to do that though because I see a bit faster way. RT is my entire segment, but I already figured out RS, which is half of the segment. So in other words, RT is going to be 2 times RS. RS we know is 23 units. 2 times 23 is 46. So RT is 46 units. All right, so that's midpoint on a number line. Not too difficult. The part where midpoint gets tricky, where we're getting into those longer example problems, is when we put it on a graph. When we do a midpoint problem on a graph, we're going to use something called the midpoint formula. This midpoint formula will allow us to find a coordinate on a graph or a point in the middle. So our midpoint formula is this big thing in parentheses, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That's going to be the point. Those x1, x2, y1, y2, those are going to come from our two endpoints. You'll see what I mean later on when we do an example. If you get the subscripts mixed up, like for example, if you were to do x2 plus x1 divided by 2, it doesn't really matter. You're doing addition and then dividing, so you're going to get the same answer either way. So half the time when I do these problems, I don't even write down the subscripts, so I don't expect you to do that either. All right, let's see an example. The endpoints of PQ are P at -3, 6 and Q at 7, -2. I want to find the coordinates of the midpoint M. I already threw a line up here just to save us some time. So this is P at this end. This is Q down at this end. I want to find the middle of that line. In order to do that, I'm going to use my midpoint formula. That formula again was x plus x over 2, y plus y over 2, and that's going to equal my midpoint. In order to use the formula, I have to plug in some numbers for x and y. Those are going to come from my two endpoints. So P, that's going to give us x1, y1, Q, that's going to give us x2, y2. If you flip-flopped them and got your 1s from Q and your 2s from P, that's perfectly fine. And then we're going to plug in these numbers. So I've got a -3 and a 6. I've got a 7 and a 2. And I'll fill in everything else. So that is my midpoint. -3 plus 7 divided by 2, comma, 6 minus 2 divided by 2. That's not very pretty, so we're just going to simplify those two fractions a little bit. -3 plus 7 would be 4. 6 minus 2 would also be 4. 4 divided by 2 is 2. So my midpoint here is going to be the point 2, 2. We'll throw it on our graph to see if that makes sense. Midpoint would be right there. Let's call it M. Yeah, that looks like about the middle. Creates two congruent segments. PM and MQ are going to have the same measure. We can also use this midpoint formula to find a missing endpoint if we are given one endpoint and a midpoint. So for example, the midpoint of segment AB is M at 5, 3. One endpoint, A, is at 2, -3. I want to find the coordinates of the other endpoint, B. So we're actually going to graph this one. My endpoint A is at 2, -3, so over 2, down 3. My midpoint M is at 5, 3, so over 5, up 3. So I know my line is going to start at A, travel through M. I just have to figure out the length of this line, where this line ends, so that M is in the middle. So we'll estimate it something like that for now, and we'll figure out what that endpoint is. Just like before, I'm going to use my midpoint formula, which is x plus x over 2, comma, y plus y over 2, which will equal my midpoint. Here we're actually given our midpoint though. So our midpoint is at 5, 3. That's going to be the solution to this formula. So I'm going to have to kind of work backwards. I know that A is going to give me one of my x's and one of my y's. Let's plug that information in and see what it gives us. So I've got one of my x's is 2, one of my y's is -3. So I know that this point, 2 plus x divided by 2, comma, -3 plus y divided by 2 should be equal to 5, 3. In other words, this first fraction, 2 plus x divided by 2, has to somehow equal 5. And we're going to figure out the x value that will make that true. And this fraction, -3 plus y divided by 2, has to somehow equal 3. And we'll find a y value to make that true. So we essentially have two different equations that we have to solve. On the right, in terms of our x's, I want to figure out the x where 2 plus x over 2 equals 5. And then on the other side, I want to figure out the y value where -3 plus y over 2 equals 3. Here we've got two equations to solve. We are all algebra experts. I'll multiply each side by 2 to get rid of my fraction. 2 plus x equals 10. And then I'll subtract 2 on each side. So x should be 8. And then for my y's, I'm going to multiply each side by 2 to get rid of that fraction. -3 plus y equals 6. And then I'm going to add 3 to each side so I can get y alone. Y is 9. So my endpoint is going to be the point on my graph where x equals 8 and y equals 9. Well, that's going to be the point 8, 9. Let's throw that on our graph. I go over 8, up 9. It's going to be that point right there. And that is our endpoint B. And that looks reasonable. I'd say M is halfway between A and B. Again, I know this video is long. I just wanted you to see that last one in a video example so you have something to go back and reference later on. And I promise we'll do more practice with these two last problems in class.